All right, self-balancing vehicles. How do they work? So, first thing, let's balance this club on my finger. This is what it looks like. Now, you might notice when the club falls this way, I move towards it to correct, and I get under it. Now, that's really all that a self-balancing vehicle does. You've got the body in it, the body, and you got your little wheel that spins, and maybe you've got your body and the one little wheel that spins, but either way, the body falls over. The wheel tries to move the bottom under it by rotating against the floor. So it falls, the wheel rotates. Falls, the wheel rotates. Now, all your vehicle ever tries to do is stay straight up. Now, the question is, well, how then do you accelerate, decelerate, and all that stuff? Where does that come in? And actually, it's pretty simple. It's just an accident. So, when you're the human on the vehicle and you lean forward, you're changing the weight of the vehicle. You've now added a weight on the front, and that's going to make it always fall this way because it's heavier on this side. Now, if it's always falling this way, right, the balance point would actually be here, but the vehicle is trying to stay flat. So the wheel is going to constantly have to roll this way to keep it upright and stop it from falling. Rather than, if it went here, it could stay in the same place, but it's not. It's staying here. It's got to keep going. You lean back to decelerate, to brake, and now suddenly it's got to start moving this way to stay nice and flat. And so that's how acceleration and deceleration works. Now, the next kind of related topic is, well, how do we know which way is up? And that's where the IMU comes in. Now, the IMU has 6 or 9 axes. Sometimes there's a magnometer. We're only using 6 of them. There's 3 axes for acceleration in g-forces, and then also 3 axes for rotation in degrees per second. I think I did the same one twice there, but you guys know what the 3 dimensions are. So normally there's not any rotational forces acting upon you. You're all zeros, and there's no g-forces acting on you in these directions, but in this direction we've got gravity. And that is really helpful because it kind of tells us which way is up. Now, you might think that the rotation alone would be enough, but the sensors just are not perfect. If the sensors were 100% perfect, you could put your vehicle straight up and just say, okay, did I leave this position? But there's all kinds of noise and issues and, just inaccuracies. So we're constantly looking for that 1G in the direction of gravity, and we're mixing the data from both of those sensors, and that's where the AHRS does its job. Now, there are simpler solutions like the complementary filter. It's an interesting one to read up, but the AHRSs that are in the VESC tool are much more complicated, but they get the job done quite a bit better. So yeah, that is how that works. I thought there was something else I wanted to say about that. Yeah, it's not that simple of a problem as you might think because you got your 1G here, you then accelerate at 1G, you've got now 1G in 2 directions and you don't know which way is up anymore. And then you hit a bump and there's a huge spike. So yeah, all kinds of things can go wrong, and that's why just figuring out which way is up is probably the hardest problem to solve in this system. So then the final part is, okay, we know which way is up and we know we want to move under, but how much should we move and which way should we move and all of that stuff. And that's where the PID values come in, and that's just an algorithm that knows kind of how to do anything basically. It's an arbitrary algorithm for getting something to a specific point, and it uses feedback on whether or not it's hit that point. Now in our case, our point is going to be straight up, and that means that uh, our attitude output from the AHRS is going to be, at 0 for, our pitch value. So the p-value in the PID basically says, we've leaned by 2 degrees, so let's send 2 degrees of current this way until we're even, and then we've fallen back, we're negative 2 degrees, so let's send negative 2 amps of current backwards, and that'll kind of work to straighten itself out. Um, and the P is kind of like how strong that force is, your P number. Your I term kind of comes in and says, well, okay, I sent 2 because I'm off by 2 degrees and it's still not working, and I tried it 3 times and it's still not working, so let's try 2.5, let's try 3, and slowly ramps up to try to make it work better over time. And the D term is kind of like, okay, we set 2 and we're going back to center, but we're going back like really fast. There's no way we're going to stop at center. We're definitely going to overshoot. So let's not send the full 2. Let's like reduce it to 1 so that we'll come to a nice even stop at center. That's kind of like a rough explanation of what the 3 values do in the PID. And that's basically all the parts of a self-balancing vehicle coming together to bring you pure joy as you shred the gnar.